Hey everyone, this is lesson 521 on perfect square equations. This is a continuation of our chapter 5 discussion on quadratics. So at this point, we've learned a number of things about quadratics. The beginning of these notes they're actually from one of the previous lessons where I kind of reviewed things you should know. So this is just a reminder, this first page of notes. It's up to you if you want to recopy this down or not. That might be beneficial to you. You might need to pause this so that you could get a good copy of it. So just as a reminder, we've covered quadratic equations, both standard form and factored form, so make sure you know the difference there. Also, note the difference between quadratic equation and quadratic function. So in this case, when we talk about function, you should notice there's the y equals. So at that point, functions are stuff we actually graph. Equations would be something we solve. So, but they go hand in hand. We'll be looking at both of those today. Also, just as a additional reminder, we did cover zero product property. This was useful when we had factored form and we were trying to solve maybe for x-intercepts or something like that. Just also a reminder, you should have seen this before, the different parts of a graph. Just make sure you make a mental note of the different parts, x-axis, y-axis, where a line of symmetry is, x-intercepts of a parabola, where y-intercepts would be. Take a mental picture of that, or pause this and draw that in your notes if you wanted to reference, which you probably already have this in your notebook if you still have the same notebook. But if you didn't copy it last time, probably take a minute to copy that. All right. The new stuff for this lesson is focused on perfect square form of a quadratic. So it's kind of like our other quadratic equations. There's the standard form, factored form. This is the perfect square form. So pretty simple, short, and really what it is it's kind of like a factored form that's been simplified and just rearranged. And so what I mean by that is you'll notice the x minus some number squared, right? This 2 means a squared, hence the perfect square, equals to some number. So it doesn't really matter what that number is. What really matters is that this one side of the equation, all you see is a square. So an example of that would be this equation I have here, x minus 3 squared. X minus 3 squared is equal to some number 12. All right, so this is considered perfect square form. As soon as you see this, I'm hoping that you could recognize, like, oh, that's perfect square form. If I, for some reason, had like another number in front, then you would say, oh, that's not perfect square form. All right, so it's little details, and there's a reason why we want it to be in this form, which is we're going to be looking at that today. So if we actually use algebra tiles, typo in here. So the algebra tiles help us kind of picture what this would look like. So x minus 3 squared, x minus 3 squared is really the same thing as x minus 3 times x minus 3, which, if we think about it, that's us multiplying like our area model, x minus 3 times x minus 3, which gives us this perfect square. Right? So what I know according to this is everything inside here should equal to 12. All right, so that's just giving you a picture, a visual of why it's called perfect square. So a couple things that you need to know how to do are, can you recognize it? So if I show you something in perfect square form, do you know it's in that form? If it's not in perfect square form, can you rewrite it so that it is? All right, so, and the reason why we would want to rewrite it is so that we could actually solve it. All right, so these are equations worth solving. These are probably one of the easier ones to solve, and hopefully after you see me work out a few of them, you kind of recognize the pattern of work. All right, so these should be a little bit easier to solve than an equation in standard form. All right, so let's jump right into this. So let's solve. Well, this one I already have worked out for us. So let me zoom into this. All right, so let's solve it. So here we have x minus 3 squared equals to 12. This is the same equation from above. Directions might say leave your answer in exact form. Right? We've talked about exact answers and approximated answers before. Another way of describing exact form is can actually be stated as a radical form. So a radical, when they use the word radical, they're really talking about this radical symbol, this radical math symbol, which usually we call it a square root. It's a square root function that uses this radical symbol. All right, so if we're going to solve this, let me zoom in to the work portion of this. So if I'm looking at x minus 3 squared equals to 12 and I want to solve this, the one issue that I have here is I'm trying to get x by itself, as usual, but there's these parentheses and this squared here. Now, a lot of times they'll try to take this and they'll say, oh, I know x minus 3 is times x minus 3. That's the same thing. But usually when students do this, the next thing they do is they say, oh, I know how to multiply that. And when they end up multiplying it, they end up with x minus 3 squared in some way. Or they simplify it back to the original, which doesn't really help. Or if they actually did multiply it out, they'd end up with x minus, I think it's x squared minus 6x plus 9, which doesn't help at all. So it just makes it more confusing. So the simpler approach is just to get rid of this squared. And the one way that we do that is by using square roots. So the opposite of squaring is square rooting. So I've taken this same equation, except you'll notice I have x minus 3 squared and I have a 12 here. The only thing I've added is this square root to both sides. In addition to that, I've also included a plus or minus in front of this square root. This is crucial. If you forget to put the plus or minus, that has a big impact on your answer. So it doesn't really matter if you put it on the first one or not. Typically, it's not done because the square root and the square are going to cancel each other out here. So those are going to go away anyways. But the plus or minus needs to stay with the square root. All right, so when we simplify this on the next line, like I said, the square and the square root kind of cancel each other out. You'll notice I'm only left with x minus 3, which is perfect. On the right side, you'll notice I kind of just left it in radical form. I left the square root and I left the plus or minus. Nothing to do here. If for some reason you reach for your calculator and you start putting that in the calculator, that's not good. Right? Don't do that. That's going to make it more complicated for you. The goal is to get x by itself. So I'm going to add 3 to both sides. That's why I have that. And when we finish, we'll end up with an answer like this. You'll notice that I put that plus 3, I put it in front of the plus or minus. This is traditionally, that's where it would always go. You want to always make sure this plus or minus number is always at the back. Right? It's always at the end. So you always want to end your answer with the plus or minus. If you put it in front, it would you could potentially have an error when we go to the next step. Most of the time, people that put that in the front start to forget about the plus or minus, and so that's not good. All right, so when we the reason why we have a plus or minus is really what that means is we have two answers. So we could actually split this up into two possible answers, and the first one you'll notice says x equals 3 plus square root of 12, and then there's a 3 minus the square root of 12. So they look almost identical, except one has a plus and the other one has a minus, which came from the plus or minus in the initial solution. So this would be an example of an exact answer, or an answer in radical form, because we have radicals in our answer. If we needed an actual decimal answer, then we would for sure need to put this in a calculator. So you would just do 3 plus the square root of 12, or 3 minus the square root of 12, and you would end up with approximated answers. Some decimal. If it's a repeating decimal, make sure you put a bar on top of it. If it's not a repeating, make sure you have at least 2 decimal places when you write out your answer. All right. All right, so what do we know about the solutions? So what does that tell us? We have 2 real solutions. So the book actually, I think, tells us you have 2 solutions, but I'm going to try to prep you for something that's coming a little bit later. Key word here is real solutions. So these are real numbers, right? This is something positive 6.46 and a negative 0.46. That's something that we could really see on maybe an x-axis. So those are real numbers. All right, so this is kind of what you need to be able to do. If I give you an equation, can you solve it? And can you tell me what the exact answer is? Can you tell me what the approximated answer is? And can you tell me what kind of solutions do we have? And is there 1 solution, 2 solutions, no solutions? That's what we're looking to do. All right, so there's, I'm going to try to go through these kind of fast. And if you need to pause it or slow it down, then I'll let you do that. But for the most part, I'm going to kind of do the same. I'm going to work out those same problems, same style of problems. But we want to look at a pattern on the kind of answers we're getting. So we're going to solve for the exact and approximated answers if we can, and see what kind of solutions are there. All right, so on this first one, so usually what I like to do is just rewrite the problem, and then I like to insert my square roots to both sides. All right, and don't forget that's a plus or minus square root on that 49. And so what that leaves us with is a 2x minus 3 equals 2 plus or minus the square root of 49. All right, so that's kind of the same steps that we did before. I'm going to add 3 to both sides. So we're left with 2x is equal to 3 plus or minus the square root of 49. And then this one actually has an extra step. There's a 2 in front of that x. So I'm going to divide both sides by 2. And so what I'm going to do is I'm going to actually split this up, and I'm going to divide 2 on both of those. Let's see if that goes okay. So this is going to be x equals to 3 over 2 plus or minus. And at this point, I'm going to take that square root of 49. That actually does simplify. So that's a nice whole number. So that actually turns into 7 over 2. All right. So what I notice is we could actually simplify that even more. So I'm going to split this up into two answers. So we're going to have x equals to 3 over 2 plus 7 over 2, and we're going to have x equals to 3 over 2 minus 7 over 2. All right, so what that does, oops, I think I need to move these other problems a little bit lower. All right, so I'm zooming in for now, but I'll zoom out in a second. So, and then we're going to combine these. So 3 over 2 plus 7 over 2 is 10 over 2, which means x equals to 5. And this one we have 3 minus 7 is a negative 4 over 2, which actually reduces to negative 2. Not two nice numbers. All right, so this tells us we have two real solutions. All right. All right, so that's kind of what we need to be able to do. Those would be considered exact and approximated answers since they're whole numbers. So I think we could stop there. There's no difference between exact and approximated on this one. All right. And then the second one, let's see. So I'm going to copy this over. I'm going to do the same steps so you kind of notice same pattern of work. I'm going to take the square root to both sides, plus or minus. And then I'm left with 7. Oops, let me use a different color. 7x minus 5 is equal to plus or minus the square root of negative 2. All right. So I'm just going to finish this off by adding 5 to both sides, leaving us with 7x equals to 5 plus or minus the square root of negative 2. Divide both sides by 7. And 7, I'll do this. All right, and then we're left with x equals to 5 over 7 plus or minus the square root of negative 2 over 7. All right, so at this point, you could split it up again. But what I notice here, and I continued the whole problem just to let you know you could solve this and you could get some type of solution. So there are still two solutions here. But the issue here is if you type this into a calculator, oops, let me use a different color. If you type this into a calculator, square root of negative 2, it's going to give you an error message. So that's not good. All right, so what I noticed, this is going to give us an error. Since this is going to give us an error, I'm going to say that there's no real solutions. Oops, no real solutions. All right, so don't confuse that with no answers, because there are answers. We solve for x. There's two possible solutions, but they're not real solutions, because if I type that into a calculator, if I type this into a calculator, it's going to give me an error message. So something fishy is going on here. All right, so this is what we're going to get into at the end of the chapter, is figuring out how to deal with these type of numbers. But for the most part, no solutions, no real solutions would be the answer. All right. All right, couple more, and then I'm going to wrap it up with one last question. All right, so on this one, so we have x plus 4 squared equals to 20. I'm going to take the square root plus or minus square root of both sides, which then leaves us with x plus 4 equals to plus or minus the square root of 20. All right, so right away I know square root of 20 is not going to give us a nice whole number, so I'm just going to leave it with the square root. I already know this is not going to give us an error, right? The difference between that one and the previous problem is the previous one had a negative inside of it, which was the issue. But I can finish this off by subtracting 4 from both sides, and we're left with x equals to negative 4 plus or minus the square root of 20. All right, so that definitely gives us two possible answers, negative 4 plus the square root of 20, and x equals to negative 4 minus the square root of 20. All right, so be careful here. Common mistake that usually happens is a lot of times when people see the plus or minus, they tend to change the 4 to plus or minus. That one still stays negative 4, right? That plus or minus only belongs to the square root in this case. So you have a one with a plus and another one with a minus. That negative 4 still stays a negative 4 on both of those answers. All right, so those would be our exact answers. And then if you type those into a calculator, those will be approximated answers. All right, so I'll let you do those if you'd like to check your approximated answers. All right, so what this also tells us is we have two real solutions, right? So far we've had two real solutions, no real solutions, and two real solutions. So we're trying to figure out a pattern, if there's a pattern to this, if at all. All right, and then one more of these. This is, let's see, 5 minus 10x equals to 0. I'm going to, squared. I'm going to take the square root of both sides. And this leaves us with 5 minus 10x equals 2 plus or minus 0. So the square root of 0, if you actually put that in a calculator, it's going to give you 0. All right, so really we're still back at 0. So what I'm going to do here is I'll leave the 10 there. I'll subtract 5 from both sides. Then I have a negative 10x equals to negative 5, right? Plus or minus 0 doesn't really do anything, so really that 0 just kind of goes away. And we're left with dividing by negative 10 to both sides. So x is equal to 1/2. All right, so you'll notice there's no more plus or minus on this one. So we ended up with, we no longer had two solutions. So 1/2 is a real number. So I'm going to say that we have one real, oops, that looks weird. One real solution. All right. Okay, so if I just look at all four of these, let me highlight these if I can. Okay, so we have two solutions, no real solutions, two real solutions, and one real solution. So you'll notice they're not all the same. And why were they different? So things to note is the ones with two real solutions, you'll notice this was equal to 49, this was equal to 20. How is that different than the others? Well, this one is equal to -2, right? It was the only one with a negative, and it was the only one with no real solutions. So when this perfect square form is equal to a negative number, you'll notice that there's always going to be no real solutions because we're going to end up with a negative in the square root. This one, why did it only have one real solution compared to two? Well, this was not a negative, but it was a 0. So the 0 kind of tells us something about the number of solutions. All right, so then how can we use that information to kind of learn a little bit about a quadratic equation? Maybe without even doing a lot of work. All right, so if you're given an equation like this, and it says, what do the solutions tell us about the graph? So if I'm looking at the graph of this equation, if I'm trying to solve, it's going to tell us, if I solve for x, it's going to tell us the x-intercepts. So when we solve for the solutions, it's going to give us an idea of how many x-intercepts there are, if any. So how many x-intercepts are there to this graph? So most likely, if I had just given you this equation before, you wouldn't have any idea, or maybe you could put it in a graphing calculator and look. But now we kind of have an easier way of telling how many x-intercepts there's going to be. And so this is what we just finished doing, so let me remind you. So I'm going to take this function and I'm going to turn it into an equation in perfect square form. So you'll notice it's not in perfect square form. So I'm going to change this to 0 equals to 5x minus 2 squared plus 6. All right, so if I wrote it like this and I asked you, well, how many solutions would there be? You might tell me, well, there's only going to be one solution because it's equal to 0, right? But the problem is this is not perfect square form, right? There's a perfect square here, but there's this extra 6, which we don't want. So let me rewrite this in the same format that we've had before. So let me change this, because usually we've had it on this side. So see if this helps you. So I want to get that 6 out of the way. So I'm going to subtract 6 from both sides so you can kind of see what this looks like. And I'm left with 5x minus 2 squared equals to -6. Now you could solve this, and it will tell you what the solutions are. But if you notice, this is now it's in perfect square form, right? And the other thing that you should notice is that this -6, right? We have a -6 here, which means, if you remember from the previous examples, when we have a negative number, right? When we have a negative number, there's going to be no real solutions. So when I go back to this problem, this tells us let me write it out here. Tells us no real solutions. So even if we tried to solve this, we would end up with no real solutions. Doesn't mean we can't get 2 answers, because we'll get 2 answers, but they're not going to be real answers. They're going to have a negative in the square root, which is not good. And so what this really means for us is there's no x-intercepts. All right, so if there's no real solutions, there's going to be no x-intercepts. So now we know something about the graph. We didn't even put it in a graphing calculator. We didn't even really solve it. All we did was we put it in perfect square form. We looked to see what that number was on to the right of the equal sign, and right away we knew something about the graph. All right, so this is huge. This is powerful. We're going to be using some of these skills in the next lesson, and you will be using this to kind of tell me more about the graphs, the parabolas we're going to be looking at. All right, that's it for this lesson. Kind of lengthy, but I think really full of information. So hopefully you've copied down all of this. If not, rewatch it and pause it in areas where you think you need to copy it thoroughly. All right, thanks for watching.